This is part 4 of using definite integration to find volume of evolution. In this part, we look at some past paper questions. The first one is taken from year 2012. There are two parts. In part A is indefinite integration question, right? We use integration by part to deal with it. So we have x sine x. I think we take the sine x dx together, right? And then x is in one color, but sine x dx is another color. We deal with the trigonometry function first, alright? And that sine x dx, we can have it into d cosine x. Alright, we have to put a negative sign. Alright, so that goes to the negative of x cosine x plus, which swap the direction, we swap the x and the cosine x, so we have cosine x dx. That is integration by part. Alright, so now is cosine x dx the integral. That is easy because that is just a simple sine x. Alright, and we put back the integration constant. This is the answer. Alright, if you're not sure, you can use differentiation to check. Alright, you can differentiate this one to see whether it indeed goes back to x sine x. Alright, you know, the accuracy of this part A is very important. If you made a mistake in part A, you will not get the right answer in part B. So in part B, we have this. We have the curve, right? Let me color it in red. It is called y is the square root of x sine x, whatever it is, all right? And we want to integrate that. We want to find the volume of the solid generated by revolving the region about the x-axis. So that means this is the volume. That is the element. If you revolve about the x-axis, you will have a disk. All right, you will have a disk. The volume of each of this disk is, first of all, the cross-section area is pi y square. That is pi y square, right? Y is the length, is the radius. And then the thickness will be dx, all right, dx. And then we try to integrate from the smallest x. X is 0, is the smallest x, all the way to the largest x. X is pi. So the integration is from 0 to pi, right? Is from 0 to pi. So the volume will be from 0 to pi, pi y squared dx. Alright, but y is x squared with x, so that is from 0 to pi x sine x dx. Now that's exactly the integration from part A. So we can just copy the result from part A. Sine x minus x cosine x. We do this integration from 0 to pi. Alright. So we have sine pi minus pi times cosine pi. Alright, and then we subtract sine 0. Sine 0 is 0. Minus 0 cosine. 0 times anything is 0. So the second term is always 0. So the first one, sine pi is 0. Cosine pi is minus 1. So the answer goes to pi squared. Alright. So 4 marks for this question. In part A is an exercise in integration by parts, alright, and then we apply the integration by part results in part B. We have to set up the integration, the formula for the volume, and then we use the result in part A to get this answer. Alright, so this is a pretty straightforward question. Now, next up, we have a more recent question. It's taken from year 2019, alright? So it defines the function log x divided by square root x. In part A, we want to prove that G has only one maximum point. So let's think about maximum point. We need to do the differentiation to investigate the maximum point. Consider G prime x, alright? We have to use the quotient rule to help us do that. That would be 1 over x, the square of root x, alright, and then I just copy square root x, differentiate log x, so you have 1 over x, and then I copy log x, and then differentiate square root x. So this is the result of the quotient rule differentiation. I guess there are some common factors you can collect from here. You get 1 over x square root x, alright, and then you have 1 minus 1 over 2 log x. Now this is G prime x, alright. So let's investigate the maximum point. We have G prime x less than 0, G prime x equals to 0, G prime x greater than 0. It depends on x, alright. when x is, when 1 minus half log x is 0, that means log x is 2, that means x is e squared. So when x is e squared, we have g prime x equals to 0. However, when x is greater than e squared, we have 1 minus log x will be less than 0, because half log x will be smaller than, will be greater than 1. Alright, so g prime x will be less than 0 when x is greater than e squared, and vice versa when x is less than e squared. So we have we can recover the diagram like this. This is y being e squared. Alright, the curve, the slope is 0 when x is e prime squared. When x is greater than e prime squared, the slope is negative number, so it goes down. G prime x being smaller than 0. Alright, but before ex squared, when x is less than ex squared, g prime x is greater than 0. Right, so it goes up and then comes down afterwards. So that means the maximum point is here. Alright, so in part A, we prove that there is only one maximum point, and that maximum point is at when x is e squared. What is the value of y? The value of y will be 1 over e. Alright, we put the e squared into here. So, I think it's 2 over e, I'm sorry. It should be 2 over e. Okay, so that is part A. Now in part B, there's no diagram, but we want to find the region bound by the curve, the x-axis, and the vertical line passing through the maximum point. Now let's think about the diagram. Right, we have the curve that exhibits a maximum point. We have the vertical line. Let me highlight it in green. Alright, the vertical line passing through the maximum point of G. Now that would be this line. Alright, that would be this line. That is the vertical line passing through the maximum point G. And with all this information, now you know this blue line is y is e squared, because the maximum point is e squared. Okay, the x coordinate is e squared. We want to find the region bound by G, bound by this blue line and the x-axis. So there must be a point where the curve G crosses the x-axis, right? We need to find this orange point now. We want to find this orange point so that we can find a complete enclosed region bound by G, the blue line, and the x-axis. And it's not difficult to find this point, because this point is where y is 0. Y is 0. In other words, that is log x divided by square root x is 0. So that means log x is 0. Log x is 0. We have log 1 equals to 0. So this orange point is the coordinate 1, 0. Alright, this is a very important aspect in this question. How do we get this orange point? So here we have the smallest x equals to 1, and then at this point x equals to e squared. So that is the boundary for the integration. It is revolving about the x-axis, so the volume will be integration from 1 to e squared. We just discussed the boundary, and that is pi y squared dx. Alright, y will be log x divided by square root x, so that is pi 1 to e squared log x divided by square root x squared dx. Right, that is the answer. If we can find the value of this integral, then we have the volume. Alright, so that goes to 1 to e squared. Now we can have this log x and then 1 over x dx. Sorry, it should be log x squared. Right, so we can do this substitution. We can let u is log x. Alright, so that we have du will be 1 over x dx. And then we have to change the boundary as well. Let us change the boundary. When x is 1, alright, u will be 0. When x is e squared, u will be 2. Alright, so you can change the integration in u. That is pi, u is 0 to 2. Log u becomes u squared. U squared. And then 1 over x log x, I just highlight in orange, will be du. Alright, will be something like this. This log x, I can change the color in blue. Alright, so that is pi and then 1/3 u's cubed. Alright, from 0 to 2. So the answer is 8 pi over 3. Alright, that is the answer to this question. The most important thing is to get the boundary correct. Alright, this orange boundary, they are elusive. Anyways, that is how we deal with this question.